Hi, I'm Elaine. I'm going to talk through the MVC model using PHP. The files for this, at least for the base system, can be found here, which I will show you. There they are. So that's the address, the web address, and you'll find them in different directories. So the client, the controller. This is for the database. So the database library of functions. This one will populate the database, and here is a copy of a database that you can use to import, and the web API, which for this version is in its simplest form. So this is for my BSc software development course, and it's the first lesson of the MVC. So you can run those files on any web server, but for the purpose of this demonstration I'm using USB web server, and I've placed them into the root directory, which, hold on a moment, here you are. So they're in the root directory of my USB web server version 8.6. This is what I've created for the baseline, just to go through and explain. So we're going to have a database with sensors and a web API that delivers the data to the controller. The data is simple, it's just an ID, a sensor ID, a status in text, I've just put OK and not OK at the moment, and a status value, also a timestamp. So that's the data, and the web API is quite a simple QRY equals A at the URL. The controller will query the web API to obtain the data, and that's just being printed out using printr at the moment, although you don't actually print anything out normally. So the controller reads sensors.php is talking to the web API and delivering data, or producing data that the view can use, and here is an example of the view that I'll take you through. So first of all, the model. The model is the database, which is MySQL for this example, and a sensors table. Via USB web server, you click PHP MyAdmin and you log in using the account details. smonitor is the database and sensors is the table. So I'm just going to query for all sensors for this example code. That's all it does. The file to query the database is dblib.inc. This is an include file, so you can place this anywhere on your system, and as long as you include it correctly, you'll be able to refer to all of these database files. Now, it's not a highly secure example, it's version 1, keeping it simple at this moment. Security will be covered at a later date. So the web API code itself uses dblib. I'll go and get that. There it is, and it's quite simple. It has a number of variables which are used by the class, and then some generic table query functions. Table query all, you pass in the SQL and then it will run a query. As said, this isn't the most secure of methods to use, but it's quite a simple way to get started. The results from querying the database go into this variable here, results, and when just querying for one item, the data goes into single value, just to make it easier to refer to and to remember, and that's just going to fetch one column, one item actually. This one is used for inserting data into the database. So that will prepare the SQL statement and run it. It would be ideal to get some data back to say how well that went, whether that was successful, but I haven't implemented that. And actually the update is the same as the insert. Again, you could do with returning a helpful message back. The getSensors function is running an SQL statement select star from sensors, so ensure that any SQL code is tested before you use it. So I'll do that now. So click into the SQL editor, make sure that your script will work, which it does. So when you have tested it, you can go back and you can ensure that that works in the code. And then this is going to run the function table query all, which is up here, passing in the SQL statement to run. So it prepares the SQL statement, it executes it, and it populates this variable using the fetch all. Okay, so it populates this results with the data. So that's get sensors. Record sensors, which is to add a sensor into the database. I pass in some data, the status and the value. This is the data required by my database. Now if you look at the structure here, you'll see that I have an auto increment ID, I have a sensor ID, and there can be repetitions of this because it's recording the status over time. Status I've just put as a varchar 3 for the purpose of this demonstration, and S value is an integer. I then have a timestamp with a default value, so the current timestamp. So I actually only need to insert into these 3 columns here because this one will auto increment and this would take the current timestamp. So going back to the code again. So record sensor will insert into sensors, into these 3 fields, the values that I've passed in. Now sensor ID is coming from the name that I pass in, which might be sensor 1. Let's have a look at that. So browse. Sensor ID is just going to be an integer, but I'm passing in, let me just go to the other page, but I'm passing in a name which you'll see shortly. To a meaningful name, it will be just sensor 1, sensor 2. It's coming from this data here, or sensor 4 or sensor 5. And I'm just breaking it apart and taking the number, and that can be added on later if required. So that's going to go into here. The status is going to be a string, so it needs the quotes around it, and I have used this backslash to say I don't want to break out of the string because that would have broken the string. This is to say I literally want to have a quote, so I'll show you that shortly. And then the value is an integer, so when that's run to record the sensor, that will actually do this insert statement. So if I take that and show you that working as well, but I need to change the data from the variable, put something like 9 in there, I haven't got one of those, and then in quotes put OK, and then in value put 3 and make that a bit bigger. So you will see now that I have 9 in there. So now I know that that works. I could use that, I could test that and add that to the script and then run the table insert query. So always test your SQL statements, make sure they work first before you actually use them. To record the data, therefore, to put data into the database, to populate it, the script that would normally be running over and over again, maybe from a sensor, is this. Now if I wanted to check what insert statements are being created, I'll just change my debug variable to 1, which will cause this to work. It will echo a message on the screen, so I'll save that. I'll add some more data into this, so I'll put 10, 11 and 12, save that, and then I'll record the data by running the script, and I've put debug 1 so that you can see what's going to happen shortly. I'm going to go to this one, go back to the get data. Get data is just to populate the database, and that's what it did. So again, if you have a problem with something not working, I've included a very basic debug option, and you can Control C, paste that into the window. Sorry, I should have done that a bit better. Copy that, paste it into the SQL window, and then if that didn't, I'll just change that to 13 because I don't think I have, or 14. And that does work. So had there been a problem, I could have printed this out on the screen like so, and then taken the insert statement and tested it out. So if there was a problem, I would have identified it. So I don't want to keep those messages. There is a problem with having messages printed on the screen. When you start to use the web API, you will find that that's a problem. So I'm going to leave that for now. I'll show you that later. So I have some more data in the database, and I'll show you what it looks like in the client. The client is a very simple program. It takes its time. Wait a moment. So at the moment I'm printing out the data from the controller. I'll change that, but then here is the data coming from the database. So I'll just take away this print statement from the controller, which is here. I'll explain that one shortly as well. And now I don't have the list. So going back to the code, the DB library, I've shown you the recording of the sensors. Now, like I said, that could be run from a script that's connected to some hardware. And finally, I have my constructor. Now, this is using USB web server. Like I said, it's not a highly secure version of the code that you would wish for, but it's a beginner version using PDO, PHP database objects, MySQL, localhost, and the port 3308. So if you're using USB web server, you need to look at the settings, and I'm running mine on 8090 because I have another one running on 8080. So the database name is smonitor, which I will show you there, and the username and password, root and USBW, which you will see when you first log in to PHPMyAdmin. Get sensor data is a public function which is going to get the sensors and return the results. This is what the web API uses. Okay, so this is the library of database functions which you can add to for the sensor database. So you can add many more queries in here. Try to use the generic functions if possible. And so when you make your own, like get sensors or get sensors between a certain date, you put your statement in there and you decide whether you are going to use table query all or table query one, which is just to give you one item back into the single value. Once you've learnt this, you should be able to put many different queries in there to obtain data for, say, one sensor or sensors between a certain date and so on. That's what you'll be doing in a future tutorial. Right, so the web API is how you obtain the data. You don't allow your client direct access to the database. So what you're going to do is make a very simple web API. I will show you that right now. So going back to this, to the browser, click on Web API, and there it is. Now this is what you receive by default. Invalid data. It's just another simple script that I've implemented for demonstration purposes, and all I'm doing is passing in query equals A, and I get my data back using that, which is all I need at this stage. Now you would implement different queries, so you, for example, query equals 1 should return back data just for sensor 1, so only items with an ID 1, but that's what you need to implement. And you can pass in query equals something else to get a date range, so date, and then you could put the dates in there, so at start equals, and then the date, and then end equals. So you could implement this in many ways by changing the URL. So this code is, there it is. The first thing it does is obtain the value in query from the URL. You can input get, so I'm doing filter input, looking at the URL for the get string, and that's the name of the variable. I'm checking if it's empty. If it's not empty and it equals an A, then I'm going to include the database library of functions, which is this one here, the one I have just gone through. I'm then going to create a new sensor database object, which is creating this, an instance of a database object. I'm then going to run the get sensor data function via the sensor database object that I have. So get sensor data will run the get sensors function, which is local, or method I should say, here, the private method, and then return the results which the method placed into this variable. If the data is empty that is received, deliver this response, otherwise deliver this response. Not perfect, I need to change these statements, but here is the data, otherwise deliver 400. Deliver responses here, so the data is being passed into the variables as can be seen, and then a header is sent back, HTTP, with the status information. The response is being built up with the status, the message, and the data. So here's the data. It's encoded into JSON and then echoed. Echoing will effectively return it to a program script that has connected to it, so connected to the web API. The header is a JSON script. So when you run this, I will show you what you get. Oh, well, you get this. So this is echoed back. But when you run it from the controller, you will not actually see all of this on the screen. So I will show you now the controller. A little issue here to remember is that you can't have anything displaying or echoing on the screen in the database function, so make sure debug is equal to 0 and nothing is being echoed out from the database. The only echo statement you can have, again none in here as well, is here. If you have any in here or anywhere else in the database library, you'll have problems. So the controller connects to this URL. Again, if you're having problems, just take this string and make sure that it works in your browser. So just ensure that you have the correct details, which they are. You would not normally hard code all of this, you would have this in a configuration file. Now I'm getting a handle to my connection, URL connection, and that's passed in, so that's connecting. It's saying I'm happy to get some data back and running the actual code, so executing the script that I've identified here, and then decoding the response so that I can extract the data. So the data was sent here as part of the response, so I'm obtaining that using my script here. So I'm just going to get the result from the response and extract the data, and this one here was to print the data out on the screen, but what I'm doing instead is I'm generating a table. So sensor table equals, and I've placed the header into single quotes so that I can keep double quotes without having to use backslash all the way through it, and then saying for each sensor data, which is what I have here, as sensor, that's just an easier variable to use. Keep adding to the sensor table variable that I started here, so this appends dot equals this line here, and I'm using the single quotes, so I need to break out of the string to add the variable, go back into the string and break out of the string again, and then go back into the string. Now this is realistically just on one line, but I've placed it over two just for ease. Again, that is all part of the same line, but it just doesn't fit on there at the moment, so making sure I haven't made any silly mistakes there by deleting things. I think I just have, so Control Z, there we are, put it back, and then after the for loop I'm going to append the end table, and that's what the controller does. It populates this variable here, it just creates a variable, and then that is used by the index file, which is here, a very simple W3 CSS sensor monitor web script, which is used in W3 Schools W3SS. I've made a div container there, just displayed the word sensors, list of sensor data. I'm including the controller here, so I'm including the read sensors file, which will connect to the web API, and then I'm just echoing the variable, and that's how that all works. So let me just go back and run the client. So we have our web API with the database, the controller that I've just shown you, and then the client, which is here, sensor monitor, as you can see, and then the list of sensors. And just to show you, we have 14, 12, 11. I will remove those, so I'll delete those from the database. Just quickly delete them. I'll get rid of all of those. So now I only have sensor ID 1 to 10, and you can see for some reason it hasn't given 10. Oh, sorry, that's because I read the wrong. So I've got 1, 2, 3, 4, 5, 6, 4, 5, 6, 9. That's what I should have on here, and that's what I have. So hopefully that's given you an overview. So what I've done is I've shown you a small database which you can download from GitHub. Let me just show you where that is again. So you'll find that in the Get Data area with the script and an XML file for you to experiment with, and you can use this to populate the database. So if you add more data in there, you can run this script, and this one will just let you get started. You need the database to be called smonitor if you want to use my scripts exactly as they are, and then the sensors table to have this structure. You have the client, which is a very simple web page, and you have the controller, which will obtain the data from the API and keep it in a variable ready web page to query it and use it. If you need to contact me, here are my details, and thank you for watching.